Hi guys, I hope everybody had a great vacation. So we are back to our algebra class, and we are going to talk about graphing quadratic functions from the standard form. And very quick review, why quadratic functions, what are they, why are we learning all about it? So I just want to remind everyone that the graph of a quadratic function form a U-shape, and that U-shape is called a parabola. And we know that parabola can look like a sad face or a happy face. And if you think about this, parabolas are quite common in the real world. Something can be shaped like parabola, or parabola can represent the motion. So if you think about something, well, here are my art skills. Here is someone, and that someone is kicking a ball. And this ball is going to have this path and is going to hit the ground somewhere here. And if you think about this motion is described by a parabola. So we are learning all about this parabola. We are learning all about the graph of a quadratic function, but it is going to help us very soon when we start working on the applications to answer many questions that we would like to know. For example, what is the highest point of the ball when you kick it? How far is the ball going? After whatever amount of time this would be, how high is the ball? Now, of course, we can go a little bit farther with this. We can create many other situations. Think about the rocket ship. Something goes up, and whatever goes up has to come down. But it is happening over a period of time. So as the time goes by, the height is changing, and then it's going back down. So if you think about this, well, this is our parabola. I want you to picture that those quadratic functions, those parabolas, they have a lot of use in real life, and we are learning all those properties. We are learning to find the line of symmetry. We are learning how to find the vertex, maximum, minimum, y-intercept, but all those things have meaning in real life. So I want you to think about this. We are so learning some skills, but those skills we will be applying very soon for the real life applications. So here we go, back to our notes. If you have a quadratic function in a standard form, well, looks like this. The first thing that you want to do is you want to find the equation of axis of symmetry. I want you to all do this like this. The equation for the axis of symmetry is negative b over 2a. So it is always a good practice to list what a, b, and c is. So remember, a is the number that goes with x squared, that's 1. B is the number that goes with x, that's 4, and c is the number that doesn't go with any variable, and that's 3. So I am going to number those guys. So number 1, I am finding the equation of axis of symmetry. Negative is in the formula. I am taking the b is 4, so negative 4 over 2 is in the formula, times a is 1. Negative 4 over 2, that is equivalent to negative 2. I know that the axis of symmetry for this parabola is going to be negative 2. I'm going to put it right away on my graph. The axis of symmetry is at negative 2. So I know that my vertex is going to be on this axis of symmetry, and I know that once I graph my parabola, if I fold my parabola along this axis of symmetry, everything should nicely overlap. All right, step number 2, I want to find the vertex, and then I want to decide whether it's a minimum or maximum. So we talked about this the other day. If a is positive, this is going to be a happy face. So there's no reflection, remember about that. So I know that my parabola is going to look like this. And I know that my vertex is going to be the lowest point, so I know it is going to be a minimum. But I do want to find the vertex. So remember, what you need to do is you need to take whatever the axis of symmetry is and plug it back into the equation. You need to be very careful. Last assignment, many of us made a mistake with the signs. So -2 is what I am plugging in, and we need to square that, plus 4 times -2 plus 3. I want you to see how everywhere in place of x, I put in -2. Again, let's not make a mistake with this one. -2 squared, that gives me +4. +4 times -2, that is going to give me -8 plus 3. 4 minus 4 is, 4 minus 8 is -4. -4 plus 3 is -1. So I know that my vertex is going to have coordinates of -2, that's the x coordinate, and -1, that's the y coordinate. So what I'm going to do is I'm going to put this right on my graph. -2 and -1. Right, this is where the vertex is. Next one, so we did this. I know that to find the y-intercept, C is going to be my y-intercept. So y-intercept is equal to whatever the C is. Now, if you don't remember y, notice that y-intercept happens when x is equal to 0. So if I plug in 0 here, 0 here, the only thing that I am left with is 3. I'm going to put it right on my graph. And once you put at this point, you can, you know that our parabola is going to be symmetric with respect to the axis of symmetry. So I am 1, 2 away, 1, 2 away. I can put this point here right away. So we did this one. We want to use the symmetry to find additional points. Well, we just did this one. And we want to connect the points with a smooth curve. Well, I want you to do one more thing. I want to see what is going to happen right in here. And some of you may remember the pattern. Well, maybe we are not going to go to the patterns. Let's plug in -1 into our equation. And let's see if x is equal to -1, where is the y going to be? So I am checking for additional points. And again, I chose the x is equal to -1. If I plug in -1, I'm going to write it above in here. -1 squared plus 4 times -1 plus 3. Let's see what this is equal to. -1 squared is 1. This is -4 plus 3. 1 minus 4 is -3. -3 plus 3 is equal to 0. So I know that for -1 I am at 0. And then using the symmetry, I know that my point is going to be right in here. Let's connect this parabola. And here we go. Done and done. So we are done with this example. And notice we graphed a parabola. This parabola has A that is positive, so the parabola is open up. The parabola has a minimum value. The vertex is the minimum. The axis of symmetry, we found that. And notice how beautiful it is symmetric. We are going to do one more example together, and then you will complete the rest of them as your assignment. All right, so now we are going to do example number 2. and we are going to follow our steps. So the first thing is going to be to find the axis of symmetry. And again, I want to remind everyone the formula is negative b over 2a. And what is b, what is a? Well, let's go back. A is equivalent to negative 2. A is the number that goes with the x squared. B is equivalent to 2, and c is equivalent to negative 1. So now if I want to figure out what the axis of symmetry is, negative is in the formula, b is 2, over 2 is in the formula, and a is negative 2. Well, I have negative 2 over negative 4. That is equivalent to 1 over 2. I know that this is my axis of symmetry. So what I am going to do is I am going to put it right on my graph right away. So 1/2, it's somewhere here. I do not have a ruler right now, so I am just going to put a line as nicely as I can. I know that my vertex is going to be on this line of symmetry. So now let's find the vertex. And to find the vertex, I know I am going to take that 1/2 that we found, and I'm going to plug it everywhere in place of x. So negative 2, look at that. This is the 1/2 that I found. We are going to square it. Plus 2. Again, I am going to multiply it by 1 over 2. I am putting the 1 over 2, my axis of symmetry, inside of the equation, because I know that my vertex is on the axis of symmetry, and -1, this is in my formula. We need to follow the order of operation. Negative 2, 1/2 squared, it's 1/2 times 1/2, that's 1/4. Plus, I can multiply those two, half of 2 is 1, and then -1 is from here. Negative 2 times 1/4, that is negative 1/2. And 1 minus 1 is 0. So what I did find is that, well, the x-coordinate of the vertex was 1 over 2. And the y-coordinate of the vertex is negative 1 over 2. So I am going to put it right on my graph. Negative 1 over 2 is somewhere here. This is where the vertex is. Now, because a was negative, I know that my parabola is going to be open down. I know that it is going to look like a sad face. And then I know that this vertex is going to be the highest point of the parabola. So I know that this is going to be the maximum. All right, next step, we are going to find the y-intercept. And we know that y-intercept equals to whatever the c is. And we know that c is equal to -1. So -1 is right in here. I want you to see how I know that my parabola is going to be a sad face. This is the maximum point. So I know that if this is at -1, there's going to be one more point that is symmetric, and it's going to be right on this side. I know that this graph is pretty small, but, well, it's a beautiful graph anyway. So we found the y-intercept. And again, like I did in the first example, I want additional point. And I am going to use x is equal to 2. It seems like a nice point. I know that it needs to be some negative number. We'll see where it is. You could use 3, you could use 4, and you can predict what is going to happen. If I use x is equal to 2, I am going to take whatever point you choose, and I am going to plug it in inside of my equation. So -2. Now, again, I chose the 2, so I am going to take 2, and then I am going to square it. Plus 2 times, again, in place of x, I am going to put 2, and then -1. So what I am doing is I am checking what is going to be the y value for x equal to 2. So let's see what happens. -2 times 4 plus 4, I multiplied those, minus 1. Negative 2 times 4 is negative 8. Plus 4 minus 1. And this is going to be equivalent to negative 5. So notice, if I am, or when I am at x is equal to 2, my y value is at negative 5. And then I know that this is going to be symmetric. So right here, now I can make my graph beautiful. Again, you want it to make like a U shape. You want to make sure that those don't look like a straight line. You may want to put the arrows. I quite often forget about that. Those parabolas will continue going down forever. Remember, we talked about the domain and range the other day. So you could choose any value of x and plug it into the equation, and you will get the value of y because the domain is all real numbers. And then the range, if anybody was asking, it's everything that is less than or equal to negative 1/2 in this case. All right, your assignment is going to do 6 examples like that, 6 exercises, and please make sure you do it the way I was solving those problems. Have fun with them.